Welcome to the Drowsy Science Channel, everyone. Thank you very much for coming tonight. We travel into the peaceful company of moonlight tonight. These itinerant partners float around both big and small worlds, influencing tides, causing atmospheres to change, and concealing mysteries beneath their surfaces. Some are ancient, mute, scarred witnesses to the history of the cosmos spanning billions of years. Others are agitated, surrounded by shifting ice, geysers, and volcanoes. Our own moon is only the first step. Titan, with its seas of liquid methane, is farther away. Europa, with its secret sea. Sparkling fountains are sprayed into space by Enceladus. Moons can have a potato form, resemble sponges, or sparkle with their own auroras. Some might even hold the chemistry of life in their arms. Understanding the moons allows one to catch a peek of the solar system's untold tales. Please think about liking and subscribing if you like these calm excursions, or leave a comment with your ideas. One drowsy soul at a time, it guides others to this place as well. You don't have to do anything, though, for the time being. Just become comfortable. Breathe slowly, allowing the peaceful rhythm of these moons to carry you. Let's get started if you're prepared. The moon is gradually escaping the gravitational pull of Earth. Our moon moves away from Earth by almost 1.5 inches per year. The moon is prodded outward by the tides, which are created when the oceans are stirred by the Earth's rotation. This indicates that the moon was considerably larger, brighter, and had a stronger pull long ago when it hung closer to the sky. It also indicates that as the planet's rotation slows down in the far future, the length of Earth's days will increase. It serves as a reminder that even something as stable as the moon's orbit is subtly shifting over time, despite how slow the process is. Our distant predecessors did not see the same sky as we do today, and our grandchildren will not inherit the same sky. There used to be an atmosphere on the moon. The moon wasn't the quiet, airless planet it is today, billions of years ago. There was a time when the moon had a thin but actual atmosphere due to the gas plumes released by volcanoes that erupted throughout its surface. Though too brittle to endure indefinitely, this atmosphere was dense enough to persist for tens of millions of years. The moon became naked and exposed as the gases slowly leaked into space. Researchers think that water molecules may have been able to enter shadowed craters, where they are still frozen, with the aid of this old atmosphere. It's simple to think of the moon as being timeless and unchanging when you look at it. However, its history reveals a different picture. There was a moment when it breathed, even if only momentarily, and then it was quiet again. There are moons that resemble flying saucers or potatoes. Not every moon is a flawless sphere. Actually, a lot of tiny ones have odd, asymmetrical forms. Phobos, the moon of Mars, resembles a lumpy potato, with a high ridge surrounding its equator created by debris swept from Saturn's rings. Saturn's tiny moon pan appears like a ravioli or flying saucer. Smaller moons lack the gravity necessary to pull themselves into a sphere, which is how these strange shapes develop. Rather, they continue to be sharp, uneven, or disc-like, serving as a reminder of their chaotic beginnings. Some were taken from roving asteroids, while others were formed from debris. Like cosmic toys strewn over space, their outlines are odd, even whimsical. These little moons feel like leftovers from the massive building of planets and solar systems, whereas huge moons appear to be worlds. There might be more water in Europa's subterranean ocean than on Earth. Something extraordinary, a vast ocean, lies beneath the ice shell of Europa. It may have more than twice as much water as all of the oceans on Earth combined, according to the evidence. Because Jupiter's gravity continuously flexes and expands Europa, producing internal heat, this ocean stays liquid, not because of sunlight. Above the concealed water, the surface is speckled with ridges and lines that indicate moving ice. On its ocean floor, some scientists see hydrothermal vents, places where minerals and warmth could combine to produce the chemistry of life. Despite its arid appearance, Europa might be one of the solar system's most favorable locations for extraterrestrial life. It conceals a world that might be brimming with possibilities in its quiet. There are oceans and lakes of liquid methane on Titan. The only known location outside of Earth with stable liquid bodies on its surface is Titan, Saturn's biggest moon. However, Titan's lakes, rivers and seas are filled with liquid ethane and methane rather than water. Rainfall and drifting clouds create landscapes that are uncannily similar to Earth's, but have strange chemistry. Picture yourself standing there with a hazy orange sky. The horizon is dotted with glistening oceans of hydrocarbons, and the air is heavy with nitrogen. Titan's peculiar rainfall and river patterns might even suggest chemical chemistry that is comparable to that which gave rise to life on Earth. It's strange and familiar at once. A frozen world where the seasons, weather, and landscapes are all shaped by a liquid that is completely different from our own. Geysers that shoot into space are ejected by Enceladus. Another of Saturn's moons, the tiny Enceladus, has grown to be one of the solar system's most intriguing worlds. Geysers erupt from fissures close to its south pole, and beneath its icy cover is a saltwater ocean. These fountains produce a brilliant plume that can be seen even from orbit as they shoot organic molecules, ice crystals, and water vapor hundreds of kilometers into space. Because of their strength, the ices contribute to the feeding of Saturn's rings. Even more astoundingly, the substance they contain points to potential microbial life-supporting circumstances. In order to taste the chemistry of these plumes, Cassini, the spacecraft that explored Saturn, sailed straight through them. We catch a glimpse of the potential for an ocean world teeming with latent energy in those glistening jets. A small moon whose magnificent, dazzling sprays continuously proclaim its presence. Nothing on Earth compares to the cataclysmic volcanoes of Io. The innermost of Jupiter's big moons, Io, is a fiery planet. There are hundreds of active volcanoes on its surface, some of which are so big that they erupt molten fountains that are miles high. These eruptions, which are driven by the tremendous tidal pressures of Jupiter and its nearby moons, surpass even the most potent volcanoes on Earth. Lava flows constantly, reshaping the entire restless Io crust. Its surface is never exactly the same from two angles. It would be impossible to stand there. The radiation is lethal, the air is thin, and the ground is shifting and seething. Io, however, shines brightly from a distance, brimming with the flaming vitality of a world perpetually in turmoil, orbiting a gas giant like a live furnace. The largest moon, Ganymede, has a magnetic field of its own. In addition to being the biggest moon in the solar system, Ganymede is particularly special. It possesses its own magnetic field. This distinction does not even apply to the planet Mercury. This field points to a deep-seated, molten metallic core. Ganymede is surrounded by a thin layer of oxygen and a frozen surface that is pocked with enigmatic grooves and craters. Because of its size, astronomers could have referred to it as a planet if it had been in direct orbit around the Sun. Nevertheless, Ganymede remains a moon orbiting Jupiter, containing geological and magnetic secrets that make it difficult to distinguish between the Moon and the Earth. It serves as a reminder that moons are more than just companions. They have the potential to be just as dynamic and intricate as planets. Life on Earth might not have developed if it weren't for the Moon. The Moon on Earth does more than just illuminate the night sky. Our planet's tilt is stabilized by its constant pole, which maintains regular seasons. Earth's axis might sway erratically without the moon, veering from sharp tilts that would result in cold ages and scorching summers. Life as we know it might not have been feasible due to such unpredictability. Additionally, the moon causes tides in our oceans, which may have fostered the chemistry of the earliest living things. In this way, the moon shapes Earth into a stable, habitable planet, acting as both a companion and a protector. It is humbling to consider that its silent presence might have been crucial to our own existence as we gaze at it now, shimmering softly above us. A devastating planetary collision created our moon. The most popular explanation for the moon's formation is both dramatic and violent. Theia, a body resembling Mars, collided with the infant Earth approximately 412 billion years ago. Molten rock and debris were launched into orbit by the impact, where they eventually came together to form the moon. There are still remnants of this apocalypse. The chemistry of the Earth and the moon is remarkably comparable, as though they were formed of the same substance. Earth was also altered by the cataclysm, maybe twisting its axis and causing the seasons to develop. What appears to be a timeless, serene presence in the sky is actually the result of turmoil and fire. An injury sustained during Earth's early history became its most devoted partner. The moon's far side differs greatly from the side that is visible to us. The near side of the moon is the one we always view when we look at it from Earth. The far side, however, is remarkably different. The far side is covered in craters and rough hills, while the close side is characterized by wide, dark plains known as Maria. Lava flows only filled basins on the moon's near side, according to scientists, because of uneven heating in the moon's early past. Before spaceships solved the enigma of the far side in the 20th century, mankind had never seen it at all for the majority of history. When I first saw those pictures, it was like seeing a second moon in plain sight, turning silently just out of sight. Triton may be captured when it circles Neptune backwards. The majority of moons orbit their parent planets in the same direction as the planet itself. The largest moon of Neptune, Triton, acts in the opposite way. Retrograde motion is the term for its reverse orbit. This peculiar trajectory implies that Triton was probably grabbed from somewhere else, possibly a minor planet in the Kuiper belt, rather than forming around Neptune. Neptune's initial moons would have been destabilized and scattered if Triton had been captured. Triton is still a peculiarity today. Ice, with a surface so smooth it appears to have just been paved, and geysers that shoot nitrogen gas into the thin atmosphere. As Neptune's gravity gradually pulls it inward, its backward orbit could eventually spell its demise. It might eventually disintegrate into a stunning ring. One day, certain moons might separate into rings. The lives of moons that orbit too near to their planets are unstable. They are pulled and stretched by the permit's gravity, and the moon can be completely destroyed if they go beyond a certain threshold known as the Roche limit. Scientists believe that Phobos, the steadily inward spiraling moon of Mars, may suffer this destiny. Phobos may break apart into debris in the far future, encircling Mars in a ring. It serves as a reminder of the relationship between rings and moons. One is capable of changing into the other. While some rings may have ripped moons apart in the early solar system, others may have merged into moons. Even while orbits appear to be timeless to us, these cosmic cycles demonstrate how dynamic and delicate they actually are. Charon is so large that it revolves around Pluto. The two entities are frequently referred to as a twin dwarf planet system because Charon, Pluto's largest moon, is so massive in comparison to its parent planet. Pluto and Charon both orbit around a common point in space known as a barycenter that is located outside of Pluto itself, in contrast to Earth and the Moon, where the smaller body orbits the larger. Charon's surface is pocked with massive cliffs and canyons, and it is roughly half the size of Pluto. The distinction between moon and planet is blurred by this peculiar alliance, demonstrating how gravity may sometimes force planets into equal dances as opposed to one-sided orbits. When you imagine them moving, it's more like two friends turning together in the dark for eternity than it is like a planet with a moon. Miranda appears to have been broken and put back together. One of Uranus's moons, Miranda, resembles a patchwork of parts that have been pieced back together. Its surface is broken up into ridges, valleys, and cliffs, some of which are higher than the Grand Canyon on Earth. According to scientists, Miranda might have broken apart in a huge collision in the past and then come back together due to gravity. Its oddly mismatched topography, where one area appears quite different from another, explains this. The most remarkable feature is Verona Rupes, the tallest known cliff in the solar system, rising up to 12 meters. It would take 10 minutes to drop to the bottom from its edge. The world of Miranda seems to have recovered from cosmic damage. In the skewed domain of Uranus, a battered survivor orbits silently. Phobos, the moon of Mars, is on a downward spiral. The larger of Mars's two minor moons, Phobos, is doomed. It gets closer to the planet by roughly 7 feet with each orbit. The gravity of Mars will either draw it down to crash into the planet's surface or split it apart into a ring in about 50 million years. There are cracks and grooves all over Phobos today, which could already be indications of this stress. Even though the moon is tiny, just 14 miles across, its fate is very much in the balance. The realization that moons are merely transitory companions with brittle orbits and unknown destinies comes when one imagines the Martian sky without Phobos. Mysterious moonquakes continue to cause the moon to quiver. The moon trembles sometimes, but otherwise appears to be silent and motionless. Moonquakes were detected by seismometers left by Apollo astronauts. Some are brought on by the Earth's gravity-induced tidal forces. Others are set off when sunlight abruptly warms the icy lunar crust, causing it to shatter under the temperature change. And some come from inside the moon itself, deeper and stranger. Their origins remain largely unknown. Because of the dry and unyielding moon's crust, which allows vibrations to reverberate, these earthquakes can persist far longer than regular ones. The moon's interior is not completely silent, despite the fact that it lacks plate tectonics like Earth. Every tremor serves as a reminder that the moon is alive with hidden energy behind its serene exterior. On the moon, trapped water is concealed by tiny glass beads. Numerous small glass beads that were created in flaming volcanic eruptions long ago are scattered across the moon's soil. Scientists have recently found that these beads have water trapped inside of them. These tiny spheres may hold enormous amounts of secret fluid despite the moon appearing bone-dry and desiccated. Such beads might potentially be collected in the future to give explorers rocket fuel or drinking water. The finding altered our perception of the moon. In addition to being a desolate desert, there are resources there that are patiently waiting in the dust. Each tiny bead has a remnant of the moon's flaming history, as well as possibly a clue to its potential as a gateway for extraterrestrial human travel. The dust, which smells like burning gunpowder, covers the moon. After walking on the moon, Apollo astronauts discovered something strange when they got back to their lunar modules. Their jackets and boots were stuck to the fine grey dust, which smelled strongly of burning gunpowder within the cabin. tiny, sharp fragments of rock and glass that have been crushed by collisions over billions of years make up lunar dust, also known as regolith. It is so sharp that it clogged equipment and tore holes in space-acute fabric. It is harsher, alien, and harmful to breathe, even if it looks like soil. That initial whiff was both unusual and memorable for the astronauts. The aroma of a world devoid of life, rain, and air that nevertheless makes its mark in the most piercing ways. Experiments that astronauts left behind are still in operation today. Many of the scientific instruments that the astronauts installed on the Moon during the Apollo flights remained operational for decades. One experiment is still in use today, a set of mirrors known as retroreflectors. From Earth, scientists point lasers at them and time how long it takes for the light to return. The precise distance to the Moon is revealed by these observations, proving that it is moving away. Long after the astronauts departed, additional research was conducted to learn more about the Moon's environment and interior. Even now, the silent Moon serves as a memory of those fleeting encounters, silent devices that gathered information in the shadows, connecting the Moon and Earth with light beams. Callisto's crust might conceal an ancient ocean. The second largest moon of Jupiter, Callisto, has more craters than practically any other planet in the solar system. It appears to be fixed in time and geologically dead at first glance. However, measurements point to a startling finding. Callisto may conceal a saltwater ocean that has been preserved for billions of years beneath its frozen exterior. If this is accurate, Callisto is a location where liquid water has silently persisted, while the surface above has not changed. Callisto is old and quiet, in contrast to the agitated ice of Europa or the volcanic mayhem of Io. Perhaps as old as the solar system itself is its hidden sea, buried under layers of ice. He might have mysteries about stability, survivability, and the extended endurance of water in the frigid outer regions of space in its stillness. The dark hemisphere of Apotus is enigmatic. The moon of Saturn resembles a yin-yang drawn on the sky. One side is as darkly discolored as coal, the other as bright as new snow. For ages, astronomers were perplexed by this remarkable two-tone planet. The most likely explanation is that while Iapetus moves throughout space, one hemisphere is covered in dark dust from another moon, Phoebe. The stark contrast we witness today results from the black parts becoming even darker after being warmed by sunshine. Another peculiar feature of Iapetus is its large equatorial ridge, which gives it a walnut-like appearance. Seldom do moons appear so oddly split, half illuminated, half dark, a celestial emblem silently circling Saturn's sphere. Like a whirling sponge, Hyperion whirls through space. One of the most peculiar things in the solar system is Hyperion, another moon of Saturn. It resembles a sponge due to its small size, uneven shape, and abundance of deep craters. The way it spins, however, is much stranger. Hyperion tumbles erratically rather than steadily, as though it has lost its equilibrium forever. Its rotation is not exactly the same in two observations. It's a mess. Because of its low density, it appears to be porous, resembling a mound of debris that is only tenuously held together by gravity. Because of this, Hyperion is both intriguing and delicate. Adrift in Saturn's orbit, a cosmic sponge that keeps bouncing in unanticipated ways. Some moons have their own auroras. Auroras do not only occur on planets. Some moons emit glistening curtains of light when they are exposed to the magnetic fields of the Earth. Auroras can be seen dancing across the poles of Ganymede, which has its own magnetic field. The charged particles racing across space can light up the atmospheres or surfaces of moons without fields, causing them to shine. Even though these auroras are not directly visible to the human eye, their brilliance is captured by spacecraft instruments. It is quite eerie to imagine a moon that is silent, airless, and capped with light from an unseen storm. A reminder that even the tiniest worlds are colored by the invisible energy that permeates space. Some moons conceal tidally heated subterranean oceans. Although many moons have oceans beneath their crusts, those that are far from the sun should be frozen solid. Tidal heating is the key. Heat is produced by friction inside a moon, as it is compressed and stretched by gravity. Even beneath miles of ice, this warmth may keep water liquid. This technique may keep secret oceans alive on Europa, Enceladus, and perhaps Callisto or Titan. Some of the most promising locations for looking for extraterrestrial life are these subterranean waters. Entire oceans may be churning beneath arid surfaces, warmed only by the constant pull of gravity. The atmospheres of certain moons are thicker than Earth's. Titan, Saturn's moon, has a denser atmosphere than Earth, which may seem unthinkable. Nitrogen and a mist of organic compounds permeate its sky. The air would press down harder than it does here if you were standing on its surface. The terrain is shaped by weather, clouds, winds, and rain because of this dense atmosphere. Titan's skies mirror those of a young Earth, providing a window into what our globe might have looked like in the past, but Earth's moon only contains a faint trace of exosphere. It serves as a reminder that moons can have habitats equally as intricate and rich as planets, making them more than just little companions. The little moon Pan of Saturn resembles a cosmic ravioli. One of Saturn's tiniest moons, Pan, has an odd shape that makes it seem unreal. It has a bulging equatorial ridge that makes it look like a piece of ravioli floating through space or a flying saucer. The way Pan moves through Saturn's rings, gathering debris that accumulates around its center, gives it its peculiar shape. It is only 20 meters broad and appears to have been hand-sculpted rather than naturally created. Pan, however, is not a toy. It contributes to the opening of Saturn's rings, demonstrating how even the smallest moons may significantly alter their environments. Mimas resembles the Death Star quite a bit. Another moon of Saturn, Mimas, rose to fame due to its striking similarity to the Death Star in Star Wars. Mima is far from threatening, although it does have the same spooky appearance as the mythical battle station because of its enormous crater, Herschel, which dominates one hemisphere. The world is just roughly 250 miles across and is frozen and damaged. The similarity is purely coincidental. Nevertheless, it has captivated the interest of everyone who has seen its image. But there's another reason why scientists are interested in Mimas. It might not have a sturdy interior. According to recent research, it might conceal a liquid ocean underneath its icy surface, making the moon appear familiar but actually much more mysterious. There are valleys in Amala that are higher than Mount Everest. Although Amla, Jupiter's moon, is small and asymmetrical, its terrain is harsh. Its surface is dotted with tall mountains and valleys, some of which are higher than Mount Everest on Earth. Amla has a slight red glow, which could be caused by sulfur from Io's volcanoes. Despite being barely 100 meters long, it contributes to the dust feeding of Jupiter's weak gossamer rings. Its striking landscape demonstrates how even the tiniest moons can contain features as large as planets condensed into tiny worlds. Despite its small size, Amtha boasts peaks and valleys that are comparable to the best in the world. One of Jupiter's most peculiar moons is Himalaya. Himalaya floats as the largest of a collection of irregular satellites, far from Jupiter's primary moons. It follows a skewed, eccentric course rather than a straight orbit like the others. According to scientists, Himalaya is a wandering asteroid that has been trapped by Jupiter's powerful gravity. Its surface is dull and grey, without the sparkling ice of the inner moons, and it is roughly 100 kilometers across. Himalaya is evidence that Jupiter collects stray objects, transforming them into moons and changing the composition of its system's population. It demonstrates to us that moons are not always created in their orbits. Occasionally, passengers are apprehended and detained indefinitely. In relation to their planets, certain moons orbit in reverse. Some moons defy their planets, but most revolve in the same direction. Contrary to the norm, these retrograde moons orbit in the other direction. Although Triton, the largest moon of Neptune, is the most well-known, several smaller moons that have been caught also travel backward. Their orbits imply that they were gathered in after traveling across space, rather than forming with their planets. The explosive nature of this capture process can occasionally break neighboring moons or alter a planet's system's tilt. Backward orbits are more than just odd. It is an indication of a tumultuous past, a reminder of the solar system's abundance of fortuitous meetings and breathtaking captures that transformed worlds into their current shapes. The orbits of Janus and Epimetheus around Saturn alternate. Janus and Epimetheus, two of Saturn's small moons, engage in a delicate celestial dance. They are in almost the same orbit, but every few years they switch positions rather than crashing. Their gravity trades energy when the inner and outer moons catch up, causing one to move outward and the other to slip inward. They are in almost the same orbit, but every few years they switch positions rather than crashing. Their gravity trades energy when the inner and outer moons catch up, causing one to move outward and the other to slip inward. Gravity itself is the choreographer of this elegant rhythm, which is repeated continuously in this orbital ballet. This unusual arrangement demonstrates how moons may form steady patterns even in unstable locations. It's like seeing a dance between lovers as Janus and Epimetheus circle Saturn in unison, never running into one another. There are moons that rotate so slowly that they hardly move at all. A lot of moons are neatly locked, with one face constantly facing the planet. Although they only spin once every orbit, it appears to us that they never do. However, some irregular moons appear nearly frozen because they rotate so slowly that it takes days or weeks. Because of their irregular forms and gravitational pulls, which gradually reduce their spin, they move slowly. Picture yourself standing on a moon like that. It might take a week to see any movement in the sky, as the stars would move so slowly. Depending on where you are in the solar system, time unfolds differently, as these sluggish revolutions serve as a reminder. The moon maintains the stability of the Earth's axis. The tilt of the Earth's axis is approximately 23.5 degrees, which gives us the seasons. That tilt may swing wildly between extreme angles if the moon weren't there. Such erratic changes have occurred on Mars, which does not have a sizable stabilizing moon. However, those fluctuations were muted by the moon's constant pull, which kept our climate comparatively constant for billions of years. Life may have flourished because of this stability, which allowed ecosystems to change and adapt without experiencing abrupt planetary upheavals. The moon has a subtle yet enduring impact on day-to-day existence. However, it stabilizes Earth's equilibrium amid the expanse of space by serving as a cosmic anchor. Over time, the moon lengthens Earth's days. Earth used to spin far more quickly. Even though a day only lasts 6 hours, energy gradually moves from Earth's spin to the moon's orbit as the moon pulls on Earth's oceans, causing tides. As a result, our days get longer as the Earth's rotation gradually slows down. We add roughly 1 today, 7 milliseconds for every 100. Although it's a minor influence, it accumulates over billions of years. The duration of a day differs from what the earliest life forms experienced. The moon has been altering the rhythm of our world and prolonging time itself just by orbiting the Earth. Lava seas once blazed on the moon. Examine the shadowy areas on the moon's surface. Ancient lava flows that have frozen in place are those wide plains. Massive impacts caused the moon's crust to break billions of years ago, causing molten rock to rise to the surface and spread into seas of luminous lava. The dark basalt plains that are visible to the human eye now were formed by the slow cooling of these many Latin seas. They inspired tales and legends because, to early observers, they resembled oceans. Their real story, however, is even more dramatic. At one time, rivers of fire glowed on the moon. Molten seas reshaped its face, leaving behind the markings we can still see every night. Shadowed craters on our moon contain frozen water. Certain craters at the lunar poles are permanently shaded. Temperatures there drop to hundreds of degrees below zero, and sunlight never reached their depths. Comets and asteroids have brought water ice to these cold traps over billions of years. Unopened since its arrival, the ice is sealed in the dark. These frozen reservoirs might supply future explorers with breathable oxygen, drinkable water, or even rocket fuel. We now see the moon as a place with hidden resources rather than just a desolate rock, thanks to the finding of lunar ice, silently waiting in the dark. Only 12% of the light from the sun is reflected by the moon. Despite appearing dazzling in the night sky, the moon is actually quite dim. Its surface is darker than weathered asphalt, reflecting just around 12% of the sunlight that strikes it. The contrast with the blackness of space creates the appearance of brilliance. In contrast to our blue and white globe, the moon would appear dreary grey if it were positioned next to Earth in space. The dusty basaltic soil of the moon is the source of its poor reflectance, also known as albedo. What we perceive to be glowing silver is actually the subtle glow of a planet that is bright enough to illuminate our nights and stimulate our creativity. Lunar soil forms glass-like cups through spacesuit fabric. Unlike earthly sand, lunar dust is not soft. It is composed of small, sharp-edged grains that are created when meteor strikes break rock into glassy pieces. These grains remained rough and abrasive because there was no wind or water to smooth them out. Apollo astronauts discovered that lunar soil adhered to everything, causing fabric to rip, visors to scratch, and seals to wear down. Because its tiny particles could become stuck in the lungs, breathing it would be risky. Walking on the moon is like entering a field of tiny, unforgiving knives. The dust serves as a challenge for any upcoming missions that return, as well as a record of impacts that have occurred over billions of years. Earth is somewhat shaped like an egg due to the moon's gravity. The moon's pull does more than simply cause ocean tides to rise. Earth itself is stretched as well. Earth has a subtle egg form due to the planet's modest bulge toward the moon. Although the effect is small and imperceptible without sophisticated equipment, it serves as a reminder of the moon's profound impact on our planet. Its gravity pulls gently but steadily through rock, water, and air. In a gravitational embrace, our planet and its moon shape each other in ways we hardly notice, but that have an impact on the entire Earth system. Planetary gravity has the power to tear moons apart. The Roche limit is a point that a moon may cross if it veers too near to its planet. The moon is stretched apart at this distance because the planet's gravity pushes on its near side more strongly than its far side. The moon may fully break if the tidal forces are greater than its own gravity. Scientists believe that a moon that strayed too close to Saturn and was torn to bits may have created the planet's amazing rings. Phobos, the moon of Mars, might eventually suffer this fate and be gradually destroyed. Even moons are vulnerable to the powerful hold of their planets, as evidenced by the notion that a solid world might break up into innumerable pieces. There are moons that are neatly locked in perfect time. Tidal locking is the phenomenon wherein several moons always display the same face to their planet. The most famous example is our own moon. We always see the same side because it completes one rotation on its axis in precisely the same amount of time as it takes to orbit the Earth. When gravity gradually slows a moon's spin until it fits its orbit, tidal locking occurs. The end effect is a balance that resembles a dance and a sort of gravitational rhythm. It establishes stability throughout the solar system, even though it implies that one hemisphere will always be hidden from its planet. Moons trapped in this perpetual rotation demonstrate how gravity harmonizes motion and time. There are occasions when moons switch orbits. Not every orbit is permanent. Certain moon couples have the ability to switch positions in a delicate gravitational exchange. The most well-known examples are Janus and Epimetheus, which orbit Saturn in almost the same direction. The inner one catches up to the outer one every few years, and their gravitational pull causes them to switch orbits rather than collide. A perfect balancing act, this cosmic swap has been repeated for millions of years. It demonstrates how even little moons may work together in unexpected ways and use motion to find stability. It's like seeing gravity choreograph the skies as they switch positions. Earthquakes and volcanic eruptions are aided by the moon. Ocean tides are not the only thing that is raised by the moon's pole. It pulls on the crust of the Earth as well. Particularly in areas that are already on the verge of activity, the tension caused by these tides might occasionally cause earthquakes or have an impact on volcanic eruptions. These are known to scientists as tidal stresses. They can also move fault lines or magma chambers at the ideal time, even though they don't directly trigger earthquakes. The idea that the moon, which is so far away, could be involved in Earth's rumblings is astounding. In addition to light and tides, the tremor of the Earth beneath our feet also connects our planet to its satellite. The layers of Ganymede's crust resemble a cosmic sandwich. There might be several oceans layered beneath Ganymede's frozen surface. Consider the following: ice, liquid water, more ice, and finally more water. A cosmic sandwich that extends for miles. Because of the tremendous pressure inside Ganymede, which forces ice and water into unique phases, this peculiar structure is feasible. Ganymede is far more complicated than a normal moon because of its molten core, which produces a magnetic field. With its oceans, magnetism, and varied geology, it possesses all the characteristics of a planet in miniature. Layer after layer of ice and water would be visible if we were to cut into it. It is a frozen structure unlike anything else on Earth. Lava flows from Io can extend for hundreds of miles. Lava flows from Io's eruptions can extend for hundreds of miles, making it the solar system's most volcanically active planet. These red-hot rivers of molten rock are constantly altering the moon's surface via cycles of regeneration and destruction. Even from orbit, some eruptions produce plumes that soar hundreds of kilometers above the ground. EOS are everywhere, transforming the entire moon into a changing volcanic environment in contrast to the dispersed Earth volcanoes. From orbit, its surface is illuminated by the recent eruption scars, serving as a constant reminder of the force of tidal heating brought on by Jupiter. The ice surface of Europa is continuously changing. The surface of Europa is a huge sheet of broken ice that is speckled with fractures, ridges, and streaks. Europa appears youthful and energetic in contrast to most moons' deeply cratered surfaces. This is because old scars are erased by its ice, which is continuously changing, breaking, and refreezing. The ice above the global ocean is kept moving by heat from tidal forces. Where salts or organics rise to the top, certain fissures may even release ocean stuff, leaving behind reddish stains. A restless world, where the frozen crust is merely a thin layer covering a living ocean, is hinted at by Europa's continuously renewed surface. The ancient craters on Callisto might be 4 billion years old. The outer big moon of Jupiter, Callisto, is a remnant of the distant past. Its deeply cratered surface resembles a frozen record of the early history of the solar system. Due to Callisto's lack of geological activity, some of its greatest impact scars may be about 4 billion years old and have been preserved. Callisto is peaceful and has little to no tectonic movement, in contrast to Europa or Io. It serves as a kind of cosmic time capsule that reveals to us the turbulent early history of the solar system. Observing Callisto is akin to gazing back through the ages into a period of history that the planet has long since forgotten. There are mountains on Titan that are higher than the Rockies. The mountain ranges on Titan's surface, despite the haze, are taller than the Rocky Mountains on Earth. These peaks are composed of solid water ice, which is as strong as stone in Titan's extremely cold temperatures, rather than rock. The rough terrain was shaped by the lifting of tectonic forces and maybe cryovolcanism. It would be unreal to stand beneath these snowy ranges, rising above methane lakes and seas, mountains of frozen water under a faint orange sky. Titan's mountains demonstrate that, although being made of different elements, landscapes may be just as spectacular and dramatic as those on Earth, even in the outer solar system. Saturn's rings are nourished by Enceladus's geysers, fissures near the South Pole on the icy moon. Enceladus continuously release ice crystals and water vapor into space. Because of the strength of these geysers, Saturn's E-ring is restored, creating a material halo that surrounds the planet. It's possible that every particle in that fragile ring was once a part of the secret ocean of Enceladus, hurled into space by tidal pressures. The delicate interaction of bodies in orbit is demonstrated by this link between a small moon and a massive ring system. Despite being only around 300 meters across, Enceladus has left its stamp on one of the solar system's most exquisite features. The surface of Triton is composed of nitrogen ice. The pale frozen surface of Triton, the biggest moon of Neptune, is sculpted by nitrogen ice. The terrain can change and smooth out over time because nitrogen ice, in contrast to water ice, is pliable and mushy at Triton's extremely cold temperatures. On the snowy plains, Voyager 2 found black streaks caused by geysers releasing nitrogen gas. Even at the frontier of the solar system, Triton is continually altering itself, as demonstrated by these geysers. Compared to other moons, its surface is remarkably smooth, indicating that this ice activity renews it continuously. Walking on Triton would be like walking on frozen nitrogen fields, where even ice exhibits odd and subtle behaviors and the everyday becomes weird. Compared to the Grand Canyon, Charon's Canyon is 4 times deeper. The chasm that scars Charon, Pluto's largest moon, is so enormous that it dwarfs everything on Earth. This enormous fissure plunges over 4 times deeper than the Grand Canyon and spans more than 1,000 miles across the surface. According to scientists, it developed when the crust ripped open and Charon's icy interior expanded. This feature is one of the solar system's most striking gashes due to its size. If it were feasible, standing at its edge would show walls that dipped into darkness. Cliffs so huge they would engulf the most beautiful scenery on Earth. Despite Charon's diminutive size in relation to planets, its landscape demonstrates that even little worlds bear enormous scars. The tallest cliff in the solar system is Miranda's Verona Rupees. One of the most amazing sights in the solar system is the Verona Rupees, a cliff that is thought to be up to 12 meters high and located on Miranda, a tiny moon of Uranus. It would take 10 minutes to descend from its edge. Scientists believe that the bar was previously broken by a huge collision and then put back together, creating a surface of rocky cliffs and twisted topography. Verona Rupes is a reminder of that bloody history. Its breathtaking scale is unparalleled in the world. It is nearly unimaginable to see a cliff 3 times as big as Mount Everest built on such a small moon. A geological marvel on a small, devastated planet. The moons of Neptune were probably taken from somewhere else. Neptune appears to have gathered its companions from the outside, in contrast to Jupiter and Saturn, which formed their moons from disks of gas and dust. The strange, slanted or retrograde orbits of many of Neptune's moons are clear indicators of capture. It is believed that before being drawn in by Neptune's gravity, Triton was a dwarf planet. The earliest moons of Neptune would have been destroyed or severely damaged by these catastrophic captures. As a result, the system appears to have been put together from pieces of the outer solar system, a group of vagrants collected in the orbit of Neptune. They serve as a reminder of how active and turbulent the solar system's past truly was, much like fossils of ancient migration. Phobos may have developed grooves as a result of disintegration. The surface of Phobos, Mars's bigger moon, is streaked with numerous fissures and grooves. Scientists argued over their cause for decades. Did rocks wander over the surface, or were they sculpted by impacts? This time, the main theme is more dramatic. The grooves might indicate that Phobos is disintegrating. The little moon is relentlessly pulled by Mars' gravity, and those forces might be eroding it from the inside out over millions of years. Its slow-motion deterioration may have begun with the grooves. If this is true, Phobos is a doomed planet that is already suffering from the wounds caused by its ultimate fate. Deimos hardly rises or sets because of how steadily it circles. Compared to Phobos, Mars's smaller moon Deimos is small, erratic, and orbits distant from the planet. Deimos seems to be a dim star, idly floating across the sky from the Martian surface because of how high and smooth its orbit is. Deimos rises and sets so slowly that it barely appears to move, in contrast to Phobos, which swiftly speeds above and sets. Observing Deimos from Mars is like witnessing a serene, soft presence that appears to be still against the vastness of space. The Martian sky serves as a theater for 2 quite distinct moons because of its quiet in contrast to its partner Phobos's drama. Some moons are so dark that they hardly reflect any light at all. Not every moon reflects sunlight and shines brightly. Some reflect only a small percentage of the light that hits them, making them as dark as coal. This group includes the Himalaya, Jupiter's irregular moon, and numerous minor outer moons of Saturn. Their black surfaces imply that they might be carbon-covered captive asteroids. Even if we were standing close by, we couldn't see these moons because they are hidden in the shadows. The fact that they are dark indicates that they came from the frigid, primordial outer solar system, where sunlight hardly reaches. They are some of the faintest nomads, worlds that murmur instead of shine. Some are so radiant that they resemble brand new snow. On the opposite end of the spectrum is a moon that is so bright that it reflects almost all of the sunlight that strikes it. Glistening like snow, Enceladus is blanketed in new ice from its continuous geysers. Of all the objects in the solar system, it has one of the highest albedos or reflectivities. It gleams like a gem against the darkness when viewed from space. This brightness is more than just lovely. It informs us of the surface's constant renewal, where soot and scars from older moons reveal their age. Enceladus and other bright ones show youth and vitality. Their sheen, which constantly changes their surfaces, is an indication of life within. Like tiny solar systems, certain moons orbit in clusters. Moons do not always orbit alone around the larger planets. Like tiny solar systems, dozens of tiny asymmetrical moons orbit in loose groups or clusters. They appear to be pieces of a single body that broke apart a long time ago, since several of them have elongated or inclined orbits. Such moon families are found on both Jupiter and Saturn. Each is a collection of broken fragments bound together by the gravity of their respective planets. The savagery of these clusters' past is revealed via study, collisions that created swarms of little worlds from larger ones. They drift together in silence today, tiny pieces that are permanently attached to the giants they orbit. The 4 Galilean moons of Jupiter revolutionized science. Galileo noticed 4 little stars traveling next to Jupiter in 1610 when he aimed his telescope at the planet. He discovered they were moons around Jupiter as they changed positions night after night. The scientific establishment was rocked by this discovery. It supported the theory of a heliocentric solar system by demonstrating that not everything revolved around Earth. The earliest extraterrestrial worlds that humans were aware of were the Galilean moons Io, Europa, Ganymede, and Callisto. They continued to be 4 of the solar system's most intriguing bodies. Each one is distinct and offers a fresh perspective on planetary systems. The first step toward understanding our position in the vast and intricate universe was their discovery. Earth is not the center, as demonstrated by Galileo's discovery of moons. Galileo Galilei saw 4 points of light close to Jupiter in 1610 when he looked through his homemade telescope. He saw them go around the world over a few nights. Io, Europa, Ganymede, and Callisto were moons, and something startling was exposed by their motion. The Earth was not the center of the universe. Galileo's discovery offered indisputable proof that planets might have their own satellites at a period when the majority of people still held the view that the universe was centered on Earth. It was a scientific turning point that upended long-held beliefs and paved the path for the current understanding of the solar system. It was more than just a discovery to see those little moons. It demonstrated that everything was not centered on Earth. Resonant orbits hold certain moons in place. 3 of Jupiter's Galilean moons are locked in resonance, a perfect gravitational pattern. The orbits of Io, Europa, and Ganymede have a rhythm of 124. Europa completes 2 orbits, and Io completes 4 for each orbit of Ganymede. By sustaining tidal heating within Europa and Io, this resonance keeps the oceans on Europa liquid and powers the volcanoes on Io. Resonances don't just happen. Over time, gravity sculpts these stable patterns into systems. The basic rhythm of orbit keeps their worlds alive, and the dance of these 3 moons is a cosmic metronome that ticks precisely across billions of years. With gravity, moons may sculpt the rings of their planets. The brilliant rings of Saturn are more than just inert objects. Shepherd moons are little moons that mold and sculpt them. With the help of their gravity, these tiny bodies pull on the ring particles, forming edges, gaps, and waves. For instance, Prometheus and Pandora heard the particles of the EF ring into a thin band, while Pan cleared a sharp groove in Saturn's A-ring. The rings would have a completely different appearance without these moons. The moon and rings interaction demonstrates how even the tiniest bodies may have a significant impact bringing order and beauty out of the chaos of innumerable icy pieces. Understanding moons is essential to comprehending how planets originate. Moons can provide information on how planets formed. Some were captured long after, others developed from massive impacts, and some originated from the same disk of material as their parent. Scientists can recreate the history of planetary systems by examining their composition and orbits. For example, the moon of Earth shows the ferocity of early encounters. The moons of Jupiter exhibit the consequences of tidal heating. Captured moons orbiting Neptune and Jupiter suggest ancient migrations, while Saturn's moons interact with rings. The tale of how planets form, crash, and settle into the systems we see today is told by these events taken together. Moons are more than simply friends. They serve as documentation of the formation of planets. Like Earth's oceans, several moons may conceal hydrothermal vents. The seas may conceal hydrothermal vents, which are locations where heat and minerals leak from the seafloor, deep beneath the ice of Europa or the crust of Enceladus. These vents are home to life on Earth, which is powered solely by chemicals and thrives without sunlight. Such occurrences might supply energy for extraterrestrial ecosystems if they occur on these moons. Enceladus's geysers jets already imply that salty, mineral-rich water is rising from the planet's depths. It is possible that life exists distant from the Sun, a parallel biology brewing in the shadows beneath alien ice, if hydrothermal vents are seen burning in those hidden oceans. It's possible that life could develop on moons in addition to planets. Planets come to mind when we think about livable worlds. Moons, however, can be equally promising. Ganymede, Titan, Europa, and Enceladus all have environments that might sustain life. Organic molecules, chemical energy, or liquid water. Life on a moon would broaden our understanding of where biology belongs by demonstrating that it doesn't require sunlight or Earth-like conditions, in contrast to barren Mars or Venus, which may be alive beneath their surfaces but hidden from view. It simply requires energy, water, and stability, all of which moons can supply. They serve as a reminder that the hunt for life is not limited to planets. Moons are capable of producing little magnetospheres on their own. The majority of moons are exposed, but Ganymede is an exception. It is protected by a tiny magnetosphere since it is the only moon known to produce its own magnetic field. The greater magnetic field of Jupiter interacts with this bubble to produce auroras that dance over the poles of Ganymede. As they move, other moons like Io create magnetic fields on their home planet, demonstrating the close relationship between magnetism and moons. A moon with a magnetic shield would be better able to shield its atmosphere or surface from radiation. These magnetic signals serve as a reminder that moons can exhibit complicated interior dynamics and behave similarly to small planets. Moon dust clouds can create unseen rings. Some moons produce weak halos around their planets due to their continuous dust shedding. For example, Amla, Jupiter's little moon, adds particles to the tenuous ring that surrounds the planet. Clouds of debris churned up by impacts can encircle even smaller moons and trapped asteroids. These rings shine dimly in spacecraft photos, but are frequently imperceptible to the human eye. They demonstrate how moons continue to influence their surroundings despite being brittle and eroded. Every bit and dust particle creates a signature that travels through space, delicately and imperceptibly connecting moons and rings. Atmospheres from certain moons escape into space. No atmosphere, no matter how small, lasts forever. Gases are sent into space by moons such as Enceladus and Io, leaving behind thin clouds. The hazy atmosphere that escapes into Neptune's orbit is fed by Triton's nitrogen geysers. Over time, Titan also loses gas to space, despite having thick skies. These leaks support fragile atmospheres, rings, or planetary magnetospheres. The gravity and temperature of a moon determine how much air it can keep or release. For many, the gas escapes indefinitely because the pull is too weak. The delicate nature of atmospheres and the way they continuously alter their parent systems are demonstrated by these leaky moons. Beyond Pluto, moons have been discovered orbiting minor planets. Many of the icy dwarf planets in the Kuiper belt beyond Neptune have moons. Con is one of Pluto's 5. Aes has at least one, and Jame has 2. These far-off systems demonstrate that satellites are widespread, even at the solar system's freezing edge, by serving as miniature representations of planet-moon connections. Their existence aids in the measurement of their parent planets' masses and the comprehension of how collisions produced these distant worlds. Every new discovery broadens the family of known moons, serving as a reminder that the furthest regions of our solar system are inhabited by companions that circle in frigid, deep space. The moons of Eris and Hea are probably veiled. Eris and Ha, 2 of the biggest dwarf planets in the Kuiper belt, are not the only ones. Whereas Hame has 2 known moons, Hyakka and Namaka, Eris has a verified moon, Dinomia. However, astronomers believe there may be more undiscovered partners orbiting them that are too weak or tiny to detect with the telescopes we currently have. Their very presence implies that moon systems originated via collisions and captures, even at the freezing limit of the solar system. These moons provide insight into the origins of their parent worlds and aid scientists in determining their actual masses. We are reminded of how frequent moons are by the fact that small, far-off objects may support their own little systems, waiting in the dark with companions. There could be hundreds more moons than planets. Even though there are only 8 primary planets in our solar system, there are more than 200 known moons, and there are probably many more that have not yet been found. Even tiny dwarf planets located far from the Sun can have companions, but gas giants like Jupiter and Saturn lead the count with dozens apiece. Moons may also form within exoplanetary systems, albeit it is more challenging to detect them. The number could be in the thousands throughout our galaxy. With a considerably greater number than planets, moons might be the most prevalent kind of solid world. Given their abundance, it is likely that moons are a natural partner of all planets, either forming or orbiting them in large numbers. There are moons that circle their almost autonomous worlds. Not every moon adheres to its planet. Some orbit so far away that they resemble captured bodies floating just within the gravitational pull of their home planet. Some of Jupiter's irregular moons, for instance, orbit well outside the major satellite groups, millions of miles away. They have the appearance of nearly independent worlds due to their slow, extended and tilted orbits. During close encounters, these far-off moons are susceptible to being pushed away or even taken by other planets. The delicate balance of gravity, where a moon can be both bound and almost free at the same time, is revealed by its shaky ties. Others hover so close to their planets that they nearly touch them. On the other end of the spectrum, there are moons that orbit dangerously near their planets. Phobos, the moon of Mars, is so close to the planet that it passes over the Martian sky in a matter of hours. Due to its tight orbit, Jupiter's Io is subject to tidal effects. Some of Saturn's inner moons pass barely above the gas giant's cloud tops, almost brushing the ring's borders. Due to their close vicinity, these moons experience crushing gravitational pressures that are pushed and stretched. Volcanic eruptions, surface cracks, or even the gradual disintegration of the moon itself are caused by their proximity. Beautiful patterns are carved into Saturn's rings by its moons. Saturn's numerous moons have contributed to the creation of this ever-changing marvel of a ring system. Larger moons use their gravity to produce spiral waves over the rings, whereas smaller shepherd moons like Pan, Daphnis, and Prometheus leave abrupt edges and gaps. The end effect is a live tapestry that tracks the unseen impact of orbiting companions through tiny ripples and crisp divisions. Saturn's rings would be a hazy mist without these moons, but when combined, they create complex, dynamic patterns. The location is among the solar system's most exquisite gravity interactions. Moons constructed a celestial artwork. Shakespearean characters are used to name Uranus moons. Uranus's moons are named after literary characters, mostly from Alexander Pope and Shakespeare's writings, in contrast to other planetary moons, which derive their names from myth. Uranus allies with names from A Midsummer Night's Dream and The Tempest include Titania, Oberon, Miranda, Ariel, and Umbriel. Because of this custom, Uranus is unlike any other planet in the solar system, and its moons have a cultural connection to human storytelling as opposed to ancient mythology. Uranus seems to be carrying a library of characters in orbit, serving as a reminder that literature and science are intertwined and influence our perception of the cosmos. The orange haze on Titan might be similar to the atmosphere of early Earth. The thick orange haze covering Titan, Saturn's biggest moon, is composed of intricate organic molecules. The conditions of early Earth may be reflected in this hazy veil, which obscures the surface from view. Similar chemicals may have been abundant in our atmosphere billions of years ago before life originated, as a result of the chemistry of sunlight-striking gases. Titan might represent a frozen moment in Earth's early history, illustrating the formation of a prebiotic atmosphere. Examining it could provide insight into the chemistry that ultimately gave rise to life on Earth, and possibly even suggest how life might develop elsewhere. Under their icy shells, or in their dense atmospheres, certain moons might contain primordial chemistry. The very chemical processes that give rise to life might occur on some moons. Titan is one possibility because of its biological haze and methane lakes. Other planets with salty seas and hydrothermal potential are Europa and Enceladus. The term prebiotic chemistry describes how complex compounds are formed from the building blocks of amino acids, lipids, and carbohydrates. This chemistry eventually developed into biology on Earth. On moons, it might have stalled before reaching that last barrier, or it might still be occurring. These locations serve as a reminder that while life is not inevitable, its seeds may spread widely throughout the universe. Future space colonies may be able to use moons as a substitute. Moons could become stepping stones as humanity looks outward. Water, ice bases in shadowed craters on our own moon are already a possibility. Phobos, Deimos, and other moons of Mars may be used as staging areas for missions to the planet. Titan provides radiation shielding due to its dense atmosphere. Although they are far away and difficult to reach, these worlds could serve as safe havens for human outposts, or perhaps permanent colonies because of Ganymede's magnetic field. Moons might eventually play a similar role in human expansion as continents did for the explorers of Earth. Earth's initial barrier against impacts is the moon. The moon on Earth does more than just illuminate the night sky. By diverting or intercepting meteoroids that may otherwise strike Earth, it serves as a guard. Over billions of years, its scarred surface is a record of innumerable collisions. The moon lessens the number of hits that Earth gets, but not all risks are eliminated. Additionally, it maintains Earth's tilt, avoiding drastic changes in climate that may endanger life. The Moon has really served as a stabilizer and a shield, keeping Earth a somewhat safe place for life to flourish. The history of our planet would have been far more brutal without it. In the past, when there were eclipses, the Moon would shine crimson. Lunar eclipses have caused the Moon to turn a deep blood red for as long as people have been observing the skies. When Earth passes squarely between the Sun and the Moon, its shadow is projected on the lunar surface, creating this breathtaking spectacle. The Moon glows red rather than disappearing in the dark because sunlight is bent and filtered by Earth's atmosphere, which scatters blue light and only allows warm tones to pass through. This was interpreted as an omen by ancient watchers, a fiery metamorphosis of the night companion. However, we now know that sunsets are red due to the same process. The Moon turns into a massive red mirror of all the sunrises and sunsets that occur simultaneously all across the planet. When planets migrate, moons may be swallowed. The starting point of planetary systems is not always maintained. Over millions of years, giant planets frequently pull moons with them as they drift inward or outward. While some moons make it through the trip, others are sucked up by the gravity of their home planet or lost to space. While other moons were probably eaten long ago, scientists believe that Neptune's moon Triton was grabbed during such migrations. The uneven satellites and odd orbits of many distant worlds can be explained by migration. These moons' histories serve as a reminder that cosmic systems are dynamic. The vast rearrangement of planets causes them to shift, shuffle, and occasionally sacrifice their satellites. Some moons were produced by collapsing rings. Not all moons form in the same way. Some smaller moons may have formed from Saturn's rings, according to experts. Moonlets gradually developed from frozen particles in the rings that gravitationally clustered together. These eventually gained enough mass to form tiny moons that orbited the edge of the ring. This procedure demonstrates how a planet's ornaments can give birth to moons. Saturn's moons might be the offspring of its glistening rings, delicate, dazzling nurseries where gravity creates enduring partners, just like Earth's moon most likely formed from a massive impact. Comet impact traces may be found on moons. The scars of every hit are preserved throughout billions of years by the moon's airless surfaces and lack of weathering. Comets, which are ice bodies that contain water and organic molecules, were responsible for some of those hits. Comets may have brought elements essential to chemistry, possibly even the seeds of life, when they collided with moons like Europa or Ganymede. Moons are time capsules, unlike Earth, where geology and weather obliterate ancient data. The frozen remnants of those cometary visits might still be present in them, keeping a record of the cosmic gifts that once descended into the solar system. After earthquakes, the moon echoes like a bell. Apollo astronauts made an unexpected discovery when they set up seismometers on the moon. The vibrations reverberated for hours, following moonquakes brought on by tidal pressures or strikes from meteorites. With a hard, dry crust that transmits seismic waves far longer than Earth's dampened rocks, the moon rang like a bell. The moon's structure, particularly its solid mantle and broken outer shell, was greatly exposed by this uncanny quality. The ringing was a gift to scientists, enabling them to investigate the moon's interior. For the rest of us, it gives Earth's partner a spectral oddity, a universe that, when hit, hums. There are lakes and rivers of liquid methane on Titan. Other than Earth, Titan is the only planet known to have stable liquids on its surface. However, beneath a dense, foggy sky, its lakes and rivers are filled with liquid ethane and methane rather than water. while branching rivers sculpt valleys via their icy crust. Vast oceans like Kraken Mare span hundreds of miles. Earth's hydrological cycle is mirrored in this alien one. Methane evaporates, condenses into clouds, rains, and replenishes lakes. Titan challenges our conception of what a living landscape in space looks like by demonstrating that familiar processes can exist on other worlds with very different elements. Tiger stripes cover the south pole of Enceladus. Under its icy exterior, the moon Enceladus of Saturn conceals an ocean. However, the surface splits into lengthy, parallel fissures known as tiger stripes toward the south pole. From them, ice and water geysers exploded into space, supplying fine particles to Saturn's E-ring. In contrast to the surrounding ice, the tiger stripes appear warm, maintained in motion by the moon's interior being flexed by tidal forces. They expel biological materials and salty water into space, offering a clear view of Enceladus's ocean. These stripes are more than just geology to scientists. They are openings into a secret sea that might be home to life. The ocean on Europa has more water than all the seas on Earth combined. Beneath the frozen surface of Europa, one of Jupiter's Galilean moons, lies a massive ocean. According to estimates, the volume of this ocean is more than twice that of all the water on Earth put together. It is warmed by tidal heating from Jupiter's tremendous gravity, while trapped beneath miles of ice. Because of this, Europa is among the solar system's most promising locations for life searching. Spacecraft have discovered plumes that indicate water occasionally bursts into space, and its smooth, broken surface suggests activity below. The hidden ocean of Europa is a vast, invisible ocean, a frozen crust covering a whole planet of water. Certain moons are gradually encroaching on their planets. Not every moon has the potential to endure. For instance, tidal forces are drawing the Mars-moon Phobos closer as it slowly spirals inward. It will either smash into Mars or fragment into a ring in roughly 50 million years. Depending on their size, orbit, and the tidal forces of their planet, other moons suffer similar outcomes. Although these slow death spirals take place over incredibly long periods of time, they serve as a reminder that even moons are temporary. When they are eaten by the worlds they circle, their futures may entail violent endings when their orbits change. It's possible that distant moons are objects that were taken from the Kuiper Belt. The orbits of several of the erratic moons that circle big planets are oddly skewed or even reversed. These hints imply that they were caught rather than forming where they are. Some might have originated in the far-off region of frozen bodies outside of Neptune, known as the Kuiper Belt. It is believed that Triton, Neptune's largest moon, was previously a Kuiper Belt object that was pulled in by Neptune's gravity. Captured moons are brought inside from the cold border of the solar system, bearing the fingerprints of far-off locations. As evidence of a dynamic system in which planets and moons exchange bodies over billions of years, they are cosmic migrants. Some moons are so tiny that they resemble enormous space pebbles. Not all moons are massive spherical worlds. Many resemble captured asteroids rather than true moons, with a diameter of only a few kilos. For example, Mars's Deimos is merely a lumpy rock that is only 12 kilometers across. Dozens of these small, asymmetrical satellites, some less than a mile across, orbit Jupiter and Saturn. They continue to tumble through space as jagged, potato-like forms because they lack the gravity to pull themselves into round shapes. Despite their seeming insignificance, these tiny moons are cosmic fossils, remaining building blocks from the formation of planets that have been kept in orbit as opposed to being ingested or destroyed. The size of other moons rivals that of planets. On the other end of the spectrum, some moons are so big that they might as well be regarded as planets. The largest moon of Jupiter, Dani, is bigger than Mercury. The atmosphere of Titan, the biggest planet on Saturn, is thicker than that of Earth. Io2 and Callisto are significantly larger than our own moon. Astronomers would consider them to be planets if they had a direct orbit around the Sun. Rather, they orbit enormous worlds, companions so big that they have their own atmospheres, magnetic fields, and geological processes. These moons make it difficult to distinguish between a moon and a planet, serving as a reminder that in a diverse world, labels are frequently arbitrary. The coldest known locations in the solar system are the moons. The coldest temperatures ever recorded in our solar system were found inside craters on Earth's own moon, not on the far-off planet Pluto. Spacecraft have measured temperatures as low as -410 degrees Fahrenheit in permanently shaded areas close to the lunar poles where sunlight never reaches. These areas are colder than the outer Kuiper belt or even Pluto's surface. Water ice is locked up for billions of years by the cold darkness. The moon's coldest regions could eventually become stepping stones for space travel thanks to these ice traps, which could supply explorers with materials and fuel. Some moons emit enough reflected light to create shadows. Enceladus, Saturn's moon, reflects nearly all of the sunlight that strikes it because it is coated in dazzling new ice. It shines so brightly because of its stunning reflectivity that it can create shadows in space. Enceladus seems ghostly against the dark sky because of this albedo, a measure of reflectivity. Additionally, other moons reflect enough light to make their orbits glaringly bright. Like cosmic mirrors, these luminous worlds disperse sunshine everywhere. They are more than just beautiful. Additionally, it provides astronomers with information on the makeup of their surfaces, exposing old, darker rock, fresh ice, or clean frost. Because there is no wind on the moon, astronaut footprints are still there. Crisp prints were left on the soft lunar regolith by the Apollo astronauts' boots as they stepped onto the moon. The moon doesn't have an atmosphere, wind, or rain to wash them away like Earth does. Those footprints, rover tracks, abandoned equipment, and even the American flags are all still there without any erosion. Most likely they will last for millions of years, marks of humanity's initial forays beyond Earth that are silent. Each print serves as a reminder that the moon is both a permanent repository of human accomplishment and a natural satellite, capturing a moment in time. Some moons are still forming because they are so young. Not every moon is very old. Small moonlets have been observed by astronomers forming around the fringes of Saturn's rings. These are new moons formed when ice particles gather due to gravity. They might eventually get bigger and separate from the rings completely to become stable satellites. This procedure demonstrates that moon formation is a continuous reality rather than only a tale from the distant past. Around a massive planet, we might be seeing the birth of new partners in real time. It serves as a reminder that creation and change are still occurring in our solar system. After devastating collisions, moons may break apart and then reassemble. Moons lead perilous lives. They can be totally shattered in collisions with other bodies. However, occasionally, gravity reassembles the pieces, giving the moon a new form. One possible outcome of this process is the ravioli-like look of Saturn's little moon Pan. According to astronomers, a massive impact that ripped apart a body resembling Mars is what gave rise to Earth's moon. These violent beginnings demonstrate that moons are robust survivors that can be destroyed and rebuilt rather than delicate ornaments. Scars or structures that reveal cosmic violence and the ability of gravity to rebuild can be found on every moon. There are still many mysteries surrounding the origins of several moons. The origins of many moons are still unknown, even though we know that some formed from impacts, some via capture, and some from merging disks. Although the specifics are up for contention, Triton's backward orbit points to capture. It's possible that collisions between larger satellites gave birth to some irregular moons. Even the moon of Earth, which was originally believed to have a single distinct genesis, might have a more nuanced past than can be explained by the traditional massive impact explanation alone. Scientists continue to investigate these puzzles, assembling data from craters, compositions, and orbits. The narrative of each moon is a jigsaw that fits into the larger pattern of world formation. Exomoons may be considerably odder than those we are familiar with. Astronomers are starting to get glimpses of potential exomoons outside our solar system. Although none have been verified yet, speculations indicate that moons orbiting far-off exoplanets might be odder than anything in the vicinity. Some would circle gas giants near their stars to enjoy the warmth. Others could have liquid seas and dense atmospheres the size of Earth. Some might even support life. Exomoons are still intriguing mysteries that need to be confirmed by more advanced telescopes because they are so difficult to find. The first real finding will be groundbreaking evidence that moons are not only widespread throughout the galaxy, but also incredibly varied. Planets rarely travel alone, as moons remind us. A pattern becomes apparent as we scan the solar system and beyond. There are nearly always companions on planets. Moons are found everywhere, from the lone moon of Earth to the crowded family of Saturn, from small asymmetrical satellites to massive giants like Titan. Their planets are shaped, their tilts are stabilized, tides are produced, rings are fed, and occasionally they have their own oceans. They are essential components of planetary systems rather than afterthoughts. Moons serve as a reminder that the universe is rarely isolated. The majority of planets are part of partnerships that are ensnared in a gravitational embrace rather than being lone wolves. Thus, our silent voyage through the moons comes to an end. From the silent footprints and luminous eclipses of Earth's own partner, we have ventured to the cold geysers of Enceladus, the flaming volcanoes of Io, and the frigid oceans of Europa. Moons larger than planets, moons shaped like potatoes, and moons still forming in Saturn's rings have all been observed. Each one serves as a reminder that the cosmos is full of friends that orbit in a never-ending rhythm. Allow your thoughts to softly orbit like moons around a planet as you fall asleep. The sense of grandeur, of peaceful worlds in orbit, of time spanning billions of years. There is no need to cling to the minutiae at this point. Moons are one of the most exquisite whispers in the night sky, which is rich with tales. Please consider liking and subscribing if you have appreciated this gentle exploration of science, or posting a kind remark in the comments. One drowsy passenger at a time, it also helps others find their way here. But for the time being, let the day pass. Allow your breathing to settle into a quiet, relaxed orbit of its own. Picture yourself floating weightlessly around a soft, invisible center indefinitely, like a moon illuminated by pale stars. Rest well, have a good dream, and may your night be as serene as the calmest moon. Good night, till we cross paths again in the upcoming video.